So welcome everybody to this latest video on 162 Maths, and in this video we'll be continuing with preparing for the GCSE Maths exam of 2022, going through the advanced information regarding the Foundation Paper 2 with a focus on the Algebra section. And in this video what we'll be doing is we're going over the topics that are on the list, what to revise, and there'll also be links to lessons that go through each of the individual topics in the description below, and there'll be a link at the end of the video where you can practice some past exam questions all relating to the topics on the Algebra section. So here is the list of topics that are on the Algebra section of the Foundation Paper 2. Now, as you can see from the list, I would say that a lot of it's going to be related to graphs and your basic skills of algebra, of expanding brackets, collecting like terms, and solving equations, which I think you would have generally spent quite a lot of time in class time. And what we're going to do in this video is just quickly go over what each of the topic kind of means and the typical questions that you could get asked. Now, if you're wanting some sort of advice or some lessons or on these particular topics, then I'll include links to each of these particular lessons in the description below, and at the end of the video there'll be a link where you can practice some questions. So let's get started on the equation section. So equations, linear just means single x's, so you're not going to be dealing with quadratic equations if you have covered that. Now, the key thing to remember when you're dealing with equations is that your final answer should be x equals, or whatever the letter that they're using in the equation is going to be. So always make sure that your end answer is x equals, not 2x, not x plus 3, x equals. And if you do find that your answer is a decimal number, try and write it as a fraction. Obviously, if your decimal is terminating, so for example it's 2.5 or 2.3 or 1.75, then writing it as decimal will get you full marks. But if your answer is a recurring decimal, then it's always best to leave it as a fraction. There is no insistence that if you end up with an improper fraction that you need to convert it to a mixed number unless it's obviously specified. So if you leave your answer as a mixed number, again, that should be fine. If you want to be better safe than sorry and you want to convert it into a mixed number, then that's also going to be fine as well, as long as it is correct. Now, in terms of the types of equations you can get that relate to linear equations, obviously you're looking at one-step equations. Now, again, I can't go through all of them, but there will be some good exam question examples of these in a link that I'll put at the end of the video. So one step will basically involve either 2x equals, let's say 6, x over 3 equals 9, x plus 3 equals minus 5, and x minus 6 equals 10. You also could have a negative x where you've got something that looks like this, but that's generally one step where you've just got to do one mathematical operation to find out what x is. Two-step is obviously doing it twice, so a two-step equation would look something like 2x plus 3 equals 6, or x over 3 minus 5 equals 10. So something along those lines where you've got to do two operations. Now, when it moves on to fractions, that's basically looking something like this. Now, remember that if you have 2x over 3, that's the same as 2/3 of x. So you can obviously use your calculator to remove that 2/3, just divide and go from there. Obviously, if you have something a little bit more complex like this, then obviously what you'll need to do here is you could split up into two separate fractions, but I would personally take the 6, take the denominator over to the other side to then make it a single-sided equation. When it comes to brackets, obviously you want to expand them first, and then double-sided equations. So is when you've got x's on both sides. And when you've got x on both sides, you always want to remember you want to get rid of the smallest amount of x from both sides. So here I would take away 2x, that becomes x minus 4 equals minus 4, and then you just go on to solve it in a single one-step approach. Now, in terms of equations, this could also be linked to other topics where you're looking at perimeter or area of a shape, or even some of the sort of I've seen them on pie charts, I've seen them on angle questions. So just be mindful that it's not always going to be a sort of basic algebra question. It could, with equations, it could be linked in other topics that are on your advanced information list. Let's move on to equivalent expressions, and I noticed that some missing off the screen, so let's quickly that and back up. So with equivalent expressions, this is quite a newish question, and I've seen in the past papers, I've seen them appear more in the multiple choice questions. So an example would be that if you had, let's say, 4x plus 8 over 2. And what you want to do is you want to then circle an equivalent expression. Now with this, you should be able to notice that with all the numbers, they're all multiples of 2. So what I could do is I can divide both these things by 2. So that becomes 1. So what I'm left with is 4x plus 8 all divided by 2 can be written as 2x plus 4. And this here would be an equivalent expression. So again, this is very, very similar to equivalent fractions. So it's just things about cancelling things down. So for example, you could have something that looks like 4x plus 4. And you've got multiple options, and you then think, oh, let's expand the bracket so we get 4x plus 16. So you want to look for 4x plus 16 in one of the options, then obviously circle that one. So it's just about collecting like terms or expanding brackets in a multiple choice. And again, it kind of links in with the other topics that we're going to move on to. So again, it's also linked with simplify, expand, and factorize. Moving on to terms. So this is again, going through what terms are. Now I would say this wouldn't be a standalone topic, question, sorry. It's going to be involved in another question. So terms you probably link with sequences, but again, sequences not on the revision list. So this is more likely going to be collecting like terms or terms being used in factorizing or multiplying out brackets. I think that's one of the reasons why they have written it. So it's really important that you understand what a term is. Now a term is basically something being added or subtracted. So if I had 2a plus 3, then here I've got two terms, one being 2a, one being 3a. If I had 3a plus 4b minus 3c, again here I've got three terms. If I had 3x plus x squared, even though I've just got x's, I've still got two terms because I've got two things being added or subtracted. And again, this particular topic can also be linked with factorization and multiplying out. So even though this topic does appear on the list, I wouldn't say it's something that you can revise individually. It's going to be used in other areas of algebra. Moving on to multiplying out brackets. Now you've probably done this to death in class, but again, it's really good that it's on there. But again, just be mindful that it's not going to be worth that many marks, so I wouldn't be fearful too much. So with multiplying out, it's about expanding the brackets. You need to be able to expand single brackets, multiple brackets, and then collect the like terms. So a single bracket question would look something like this. And again, there's different variations of single brackets. You could have letters outside. So for example, you could have this, where that's going to be a squared plus ab. This is going to be 4x minus 16. You could also have multiple single brackets. So that's where we've got x plus 2 minus 3, 2x minus 4. And again, just be extra mindful when you have got negatives outside the brackets and also inside the brackets, and remember to use your knowledge of negative numbers and when you're multiplying. Double brackets again would be could be on there as well, so just make sure that you're able to know how to expand double brackets. Again, two of the most popular options of expanding brackets is either using loops, or you could use FOIL, or you could use the grid method, which I know a lot of students tend to use as well. So here we've got x plus 4, x minus 5. And again, if you're not sure, the video in the description link will go through this topic in all its entirety. Factorization, so this is basically where you're installing brackets. And again, you want to take the highest common factor of the numbers and the lowest common factor of the letters. So just be mindful of knowing how to factorize, and all terms must have common variables for it to be a factor. And again, if you're not great with, I would say from this list of algebra topics, I know that a lot of foundation students that I've taught tend to struggle more with factorization than multiplying out brackets. So just make sure that you are able to do that. These questions tend to be worth around either 1 mark if there's just one factor that can be taken out, or maybe 2 if you're not taking out the highest factor. So just be mindful of that. But I would say looking at a 2-mark question for this particular topic. Then moving on to coordinate geometry. So this is where we learn moving on to graphs. Now coordinates, again, could be an individual topic, or it could be merged with any of the topics involved in the graph section of this algebra sort of revision list. Now again, it's really important that you understand the basics. This should be guaranteed marks for you, so make sure you're able to know how to write coordinates. So remember that the first ordinate is the x value, the distance going across, and the second ordinate is the y ordinate, which is the distance going up or down. You also need to be able to make sure that you know how to plot coordinates and also find midpoints and points that complete a shape. So for example, questions I've seen done in the past is where you've got, let's say, point A, point B, and it says that point C is somewhere along this line and it makes an isosceles triangle. And so you just need to make sure you're putting C in the right place, or they like you to complete the point so it makes a quadrilateral or parallelogram. And so it's just a case of working with those questions. Again, go into any revision guide, any exam paper, you'll find questions that relate to coordinates. You also need to be able to look at completing a table of values and then use this to plot an equation. Now, equation of a line is another topic that's on this section. So again, make sure you know how to complete a table of values by substituting numbers into an equation, completing a table, and then recognizing that the table values give you the coordinates that you then need to plot. And also, again, just to summarize that this topic is linked to virtually everything that we're about to talk about next. The next thing we move on to is midpoints. So again, typically with it being in the graph section, you're going to be finding the midpoint between two coordinates. Now, typically you'll be given a graph or some squared paper and they'll have their coordinates plotted and you just need to find the midpoint. So again, there's no real technique that you have to do, but you can use a technique if you want to. So here, to find the midpoint two coordinates, now to find the midpoint two coordinates, all you got to do is to find the x ordinate, which is the first value, simply add the two x ordinates together and then divide it by 2. And then for the y ordinate, add them together, divide by 2, and you get that. Or you can alternately use this formula, which tends to be used more high level, but I would say it's not really needed. So let's just go for a quick example. So if I just pick two numbers, and let's stick some negatives in there as well. Let's stick a -2 there. So looking at this, if I look at my x ordinates, I've got -2 and -4. So here, if I add them together, so -2 plus -4 equals -6. I divide that by 2, and that gives me -3. So my midpoint is going to be -3. Then to find the y ordinate, I add my two y values together. So that's going to be 3 plus 8, which is 11. Divide that by 2, and I get 5.5. And all right, 5.5. Or I could write 11 over 2, but that there would be my midpoint. And again, also what you need to be able to also do potentially is, let's say they've got a point of A, point of M, and they want you to work out what B is. So again, here, if you look at the, let's say 3, 4, and this is 7, 8. So looking at the difference between 3 and 7, well, I need to add 4. So then I'll need to add 4 for this coordinate. So that's going to be 11. And then looking at the y ordinates, again, I need to add 4. So then I need to add 4 to 8. That will therefore give me 12. So there I can work out, if I've been given a midpoint, I can then work out what the other points are. If I didn't know what A is, I would just do the opposite and I'd take away from the midpoint ordinates, but hopefully you get the gist. Now then, let's look at points on the line. So again, for this, you need to be able to make sure you know how to write down a coordinate that lies on the line, write down the x ordinate when given the y ordinate, write down the y ordinate when you're given the x ordinate, and check and show that a point does or does not lie on a line. So for example, for the first one, so let's write number 1, you might have a line plotted and a question might say, give the coordinate of a line that a point that lies on the line. So all you need to do is just find a nice easy coordinate, write down the x value, write down the y value, and you've got your coordinate. Now, if let's say you've got a coordinate, so for example, let's say we've got y equals 2x plus 3. So a question might ask you that they may give you part of the coordinate and you need to find the other part. So if x equals 2, what's y going to equal? So all you need to do here is substitute x equals 2 into this equation. So here I've got y equals 2 times 2 plus 3, which gives me 7. So the coordinate then is going to be 2, 7. If you're given y, so let's say y equals 10, so then all I'm going to do is substitute 10 into this, which then becomes an equation, which again is a previous topic that's already mentioned. And then we just go on and solve this. So I've got 7 equals 2x, so x equals 3.5. So my coordinate then is 3.5 and 10. And then again, to check to see whether a point lies on a line. So for example, let's check to see if 2, 1 lies on y equals 5x plus 1, let's say. So for this, what you need to do is substitute x equals 2 and see if it equals 1. Now the reason why I'm using x equals 2 is because that is the x ordinate, and the reason why I'm checking to see if it equals 1 because that is the y ordinate. So if I substitute 2 into this formula, I get 5 times 2 plus 1, which is 11. So as this is not 1, it does not lie on the line. There we go. So the next one is looking at the intercept of a line C. So again, if you remember the plotting equations of a line, that the intercept of a line is most likely going to be the y-axis. So again, what you want to do here is note that you be able to state where the line crosses or intercepts, which is both the same word, the x-axis, and state where the line or crosses or intercepts the y-axis. Now, a point where a line intercepts another line, one, it may be given and you may need to plot another one. So again, it's about just recognizing that if you've got a straight line, and let me just draw a set of axes like so. Just extend this line here. So this point here is the y-intercept, and this point here is the x-intercept. Now a question might ask you that to plot another line, and again because that's another topic that's on there, and this point here would be the point where the two lines meet, so where the two lines intercept. So just working with those questions. You also need to be able to work with the y equals mx plus c, where c is the y-intercept. So for example, if I had y equals, let's say 2x minus 3, then minus 3 is where the line crosses the y-axis. Obviously not that point because that's above the x-axis, but this there will be where it crosses the y-axis. And also you need to be able to write the equation of a line when plotted. So again, another example that you've seen, you'll see this if you practice some of the exam questions that, again, I'll link to the end of this video, or watch the video relating to how to write down the equation of a line from a graph. Then it's a case of just knowing how to work out the equation of that particular line. We then move on to the gradient of a line. So to finding, you need to have to make sure you know how to find the gradient from a plotted straight line by drawing a triangle. Now it's really important you do draw that triangle and do not rub it out, because again that'll be worth a mark in itself. You also need to be able to recognize when you've got positive and negative gradients. So again, if you've got positive gradient, then that's where your line is going up. Negative gradient means the line is going down. Also with positive gradients, that's when you've got positive x when y is the subject, and it's negative when you've got negative x when you've again made y the subject. Also you need to be able to look at knowing how to write the equation of a line when it's plotted. So again, links to find the equation when you've got a plotted line, and also find the gradient between 2 points. Now if you're asked to find the gradient between 2 points, then all you then need to do is turn that into a triangle, measure this base using the scale, measure the length of, sorry, the height of the triangle and the base of the triangle, and then the gradient is the height over the base. And then obviously then remember to use the sign. Remember the sign. So if your line's going up, so this green line here you can see it's got positive gradient, but if the line was going down, then again I draw my triangle, I look at the height, I look at the base. So the gradient is going to be height over base, but it's going to be minus because the line is going down. We then move on to our last one, which is the equation of a line. Now again, with this you need to be able to know how to plot an equation. So again, they'll most likely give you a table of values. You fill that in, get the coordinates, plot it, draw a straight line. You also need to be able to recognize horizontal, vertical and diagonal lines. So horizontal lines again have y equals a number with no other letter. Vertical lines have x equals a number, and diagonal lines will contain single x's and y's with no fractions, or at least when x is in the denominator. So you also need to be able to recognize the equation of a straight line is y equals mx plus c. Again, if you're not too sure, then I strongly recommend you watch videos related to this, and again there will be links in the description that go through that. You also should be able to recognize how to plot y equals x and y equals minus x, and again this would usually be linked with reflection or things like enlargement, but I would say as that's not mentioned, then you should be fine. And also know how to substitute x and y values into an equation to write complete coordinates. So for example, this all relates to a table of values. Now again, if any of these topics do not make sense, then I strongly recommend that you click on the video links that go through the lessons and kind of go through everything you need to know about these individual sections of algebra. And if you're happy, then there'll be a link at the end of this video where it's linked to some practice and past exam questions so you can test your knowledge to see how comfortable you are with each of these topics.